Hi, I'm Amir Hossein Mirza Bozorg, and in this video I want to talk about the preview of impact simulation of composites and fiber metal laminates via Abaqus. Based on this paper, the low-velocity impact simulation of fiber metal laminates is conducted in the premium version of this tutorial. The paper studies the effect of impactor initial kinetic energy on the damage pattern of FML specimens via performing extensive experiments. The premium version of the tutorial simulates and verifies a suggested specimen with the paper results. Now I want to show you the paper. This is the paper. The duration of the main tutorial is 1 hour and 15 minutes, and the total size of the tutorial is 264 megabytes, including the videos and Abaqus files and the slides. And its tutor is Amir Hossein Mirzabozor. Modeling and simulation are conducted according to the paper explanations, like these explanations. For example, the effective region of square specimens is a 50 multiplied by 50 circular geometry at the center of the specimen. And the impactor is a sphere with the diameter equal to 12.17 millimeter. And the mass of the impactor is 6.29 kilograms, and the initial impactor energy is 12.7 joules. According to this value, we can calculate the initial speed of the impactor. This is the equation of kinetic energy for a rigid body with the angular velocity equal to 0. So, according to this equation, the value of initial velocity of impactor can be calculated. These experimental results are reported in the paper. Upon completion of this tutorial, we will be able to obtain this curve and verify our models. Now I want to talk about the modeling procedure. In the modeling procedure, we will create two models, Model 1 and Model 2. In Model 1, we will define tie constraint between each two adjacent layers of the FML. And in Model 2, we will define cohesive surface between each two adjacent layers of the FML. And both of the models will be solved using the Abaqus explicit solver. And this is the final FE model. This is the rigid impactor, and this is the FML. And as you can see, at the center of the FML, smaller elements are used because here we have a stress concentration due to the impact. And here we have large stress gradients. Now I want to talk about the results which will be obtained from the simulation. This is the contour of matrix compressive damage for one of the composite layers of the FML. And here at the center of the composite layer, we have damage, and here the damage parameter value is equal to 1. That means the damage is completed. And this is the damage initiation contour of cohesive interaction. And as you can see, in most of the regions, it is equal to 1. It means that in most of the regions, the delamination has been started. And this is the contour of damage parameter of cohesive interaction. And as you can see, at the center, it is equal to 1. In this region, we have the complete delamination. And here, layers are fully debonded. This is the experimental result reported in the paper, and these are the simulation results. The blue curve is obtained from Model 1 and the purple curve is obtained from Model 2. As you can see, the result of the second model is closer to the experimental result reported in the article, because in Model 2, the cohesive interaction has been modeled, and so it is closer to the reality. How to ask your video-related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We try to answer all questions regarding the video details in the comments below. You can contact me via Telegram or WhatsApp, or you can send email to me. We can have one-on-one tutoring on the AnyDesk WhatsApp, and we can make special tutorials to your order. We can conduct high-quality simulations for your thesis, exercises, and industrial projects. Now I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.